Hello programmers, Dan McElroy here with a discussion on how to use generative artificial intelligence to create code for a Java program. Generative artificial intelligence is also known by its abbreviation GenAI. It is important to know how to use GenAI for creating reports and generating code. For all previous discussions, I created the PowerPoint presentations on my own, complete with all the text that was then used as a script when creating a video. For this presentation, I'm not only using a generative artificial intelligence application to help create the presentation, but also the Java code for a sample program. Although the rough draft was GenAI created, I ended up doing a lot of edits and updates before making it available to students. I chose Claude.AI to help with this presentation and sample Java program. The prompts I fed to Claude are shown in quotes. I want you to take notice that I first introduced myself and then asked what I was generally looking for and then became more specific. Although being polite with please and thank you are not required, being rude is generally not helpful at all. Here are the prompts I used with Claude. Hello Claude, I teach an introductory class in Java programming at a community college. I want to include artificial intelligence in a class presentation and cover 3 topics. Can you please help me out? The first topic is a list of the many different types of artificial intelligence with a short description of each type. The second topic is generative artificial intelligence, also known as GenAI, and a short description of how it can be used to create essays, summarize meetings, and other text-based things it is capable of doing. And finally, how to use GenAI for writing software programs. I would like an example Java program that asks a user to input the number of quarters, dimes, nickels, and pennies, and then give a total. The program needs to use constants for the value of each coin type and accept only positive values for the count of each coin. Thank you, Claude. That's the end of the prompt. Here are the many branches of artificial intelligence. I'm listing them here so that you can be aware of the many differences and capabilities. We will only be concerned with generative artificial intelligence as it relates to creating software code. Machine learning AI provides systems that improve through experience without explicit programming. It uses data to train models that make predictions or decisions. Deep learning AI is a neural network-based approach with multiple layers. It processes information similar to the human brain and powers image recognition, speech understanding, etc. Computer vision is built from technology that enables machines to interpret visual information and is used in facial recognition, medical imaging, autonomous vehicles. Expert systems are programs that emulate human expertise in specific domains. They use predefined rules, for example, medical diagnosis systems and tax software. Robotics AI have intelligence embedded in physical machines and interact with the real world, including manufacturing, exploration, healthcare applications. Generative artificial intelligence, GenAI, are AI systems that create new content rather than just analyzing data. GenAI uses large language models trained on vast data sets. GenAI applications extend across multiple domains. You need to do some independent research on selecting 2 GenAI tools for assignments in this module. I am providing 2 recommended websites, but you can choose another one if you wish. Some of the popular GenAI tools for programmers are Microsoft's GitHub Copilot, ChatGPT, Google's Bard, AutoGPT, Amazon Code Whisperer, Anthropic Claude, Tab9, and CodeWP. The first Geeks for Geeks webpage listed starts with a description of GenAI and how it works. It then lists over 20 GenAI tools, their key features, pros and cons, and pricing. Not all of these tools listed are good for code generation. Although you may need to register to gain access to some of the tools, I don't expect you to pay anything or sign up for a premium version of any tool. If an email address is required, I suggest using your SJCC email address, such as your student ID at stu.sjcc.edu. Here is the code created by the Claude.AI tool. The first part of the code has the import java.util.scanner, then the declaration for public class coin counter. The contents of the class will all be within the set of open and closed curly braces. In Java, class names are expected to start with an uppercase letter. Claude did a good job of naming constants with all uppercase letters and the underscore character. I see that it is using integers for the constants, which means that it will be keeping track of the total cents instead of dollars. A block of code inside the curly braces for public static void main has the executable code for when the program runs. The first thing I see is scanner with a capital S, scanner with a lowercase s, equal new scanner with a capital S, open parentheses, system.in, close parentheses, semicolon. The word scanner with an uppercase S is a class name and gives us access to the keyboard. The word scanner with a lowercase s is an object name. What is important to remember is that a class name starts with an uppercase letter and a variable or object starts with a lowercase letter. From this point in the program, we will be using the scanner object with the lowercase s. It is my preference to use scanner stdin or scanner keyboard for the class and object names instead of scanner to help avoid confusion. Next, I see integer variables declared that will hold the count of coins for each coin type. When inputting the number of coins, this program is using a method named getPositiveInput. This method is not a standard part of Java, so it must be defined later in the program. The term method is used in object-oriented programming, or OOP, when defining a subroutine or function that is part of a class definition. The getPositiveInput method has two parameters inside the parentheses. The first parameter is a scanner object which has already been created for using the keyboard. The second parameter is a text string that is a prompt message to be displayed on the screen that will ask the user to input some specific data. We will be able to see how these parameters are used when we see the code for the getPositiveInput method. Instead of declaring int total cents at the top of the program, it is declared at the location where it is first used. The total cents variable is initialized at the same time it is declared by computing the number of each coin type multiplied by the coin value. The total dollars variable is also declared at the location where it is first used. It is initialized to total cents divided by 100.0. A double result of the division occurs because at least either one or both the dividend and divisor data types are doubles, such as 100.0. Claude chose to use a collection of printline statements for the output. The last printline statement could have been replaced with the printf statement, but instead uses the string.format method to convert total dollars into a string with 2 digits past the decimal. The scanner object is closed before the program ends with a closing curly brace that belongs to int main. We still don't have a closed curly brace that ends the class definition. Blocks of code or data are defined by pairs of curly braces. Each open curly brace must have a mating closed curly brace. You can even have another block of code nested inside another block of code. For example, the void main and getPositiveInput method are both inside the curly braces for class coin counter, because they belong as part of public class coin counter. There is a do-while loop with its curly braces inside getPositiveInput. When looking at the code for the getPositiveInput method, we will also see a while loop and an if statement, each with their curly braces for blocks of code that are inside the do-while loop. Although Claude did not put comments at each of the closing curly braces, I recommend them to help make it easier to identify where they mate to their open curly braces. Here comes the helper method. GetPositiveInput has two arguments that will be receiving the scanner and prompt message when it is called or activated by code in the main program. For each of the parameters inside the parentheses, we need to define the data type and name that will be used inside the method. The first argument identifies that we will be receiving a scanner object and we will be referring to it within the method by the name scanner with a lowercase s. The data type for the second argument is a text string, and we will be referring to it within the method by the name prompt. The first thing inside these curly braces is a declaration of an integer named value. This variable is only visible to code inside the curly braces for the GetPositiveInput method. A do-while loop is used to keep repeating a block of code that gets input from the user while a non-integer is input, or the value is negative. Look for the do-while loop's close curly brace and the while statement that mates with its open curly brace. Inside the block of code for the do-while loop is the print statement that displays the prompt on the screen. Then there is a while loop that checks to see if an integer has been typed on the keyboard. If not, the not condition is specified by the exclamation mark, then a invalid input, please enter a positive number is displayed and any characters left over in the keyboard's input buffer are cleared. If an integer is available, it is read from the keyboard using scanner.nextInt, open close parentheses, semicolon, and saved in the variable named value. If a negative value less than 0, was entered, an error message is displayed. Close curly brace, while, open parentheses, value less than 0, close parentheses, semicolon, which is the close curly brace for the do-while loop, and the keep looping condition if the value is less than 0, meaning a negative value. Then there is the close curly brace for the helper method, GetPositiveInput, open close parentheses, and then the close curly brace for public class coin counter. I used Online GDB to run the program using the code provided by Claude's GenAI tool. The output shown from running the program is at the bottom of Online GDB and is producing correct results. You have 2 lab assignments this module. Use the GenAI web application of your choice to create a Java program for a lab that you have already completed. Compare the code that is human-generated and the code that is AI created. For the second lab, it is your job to compare 2 different GenAI tools. Do not ask a GenAI tool to compare itself to another tool. Use a different GenAI application of your choice to create a Java program for the same lab project and compare not only the generated code between the 2 GenAI applications, but the steps you used for the GenAI tools and how easy or difficult it was to use each GenAI application. I hope you find this module on generative artificial intelligence both interesting and informative. I am positive that you will see it used in your future endeavors, not only in programming, but in many other aspects of your professional life. See you next time. Dan Dolph, signing off for now.